All right, so we're going to look at the Chapter 5 review for test. Number 1, a force is 10 newtons is used to pull. So remember, a push or a pull is an applied force. So my applied force is equal to 10 newtons. A chest weighing, this is the weight, a uniform speed, a distance of 5 meters, how much work is done. So we know that work is equal to FD, okay? But work is only done in the direction the force is moving the object. So only the force going in the direction of the object does work. So if I was to imagine a free body diagram of this, the chest is on the ground, the force is moving this way, and my weight acts down. Well, the object is moving horizontally, so that's the force that's doing the work. So it's going to be equal to 10 newtons times 5 meters, which is 50 joules, because a newton times a meter is a joule. So the answer to number 1 is B. Okay. Number 2, as shown in the diagram below, a child applies, so this is again the applied force, but it's acting at an angle of 25 degrees. How much work does the child do in moving it? So for number 2, we see the applied force is 20 newtons, the angle is 25 degrees, and it moves a horizontal distance of 4 meters. So W is equal to FD. This component of this force is adjacent to the given angle, and that's how we know it's cosine. So W is equal to FD cosine theta. So it's 20 newtons times 4 meters times the cosine of 25 degrees. And if we do that on our calculator, it comes out to be 72.5 Newton times a meter, so it would be 73 joules. And that is answer C. Okay. Let's look at number 3. When a machine does 250 joules of work in 10 seconds, what's the power? So for number 3, we know that power is work divided by time. So this is the joules, this is the time. So this is 250 joules over 10 seconds. A joule per second is a watt, 25 watts. So the answer to number 3 is D. Number 4. As the time required to lift the mass the same vertical distance increase, what happens to the power? So the first thing I'm going to do is I'm going to write my equation. Power is work over time. So the question asks me, as the time increases, as this gets bigger, that's increases, what happens to this? Okay. And we see that that is going to decrease because they're inversely proportional. So the answer to number 4 is A. All right, number 5. A cart has a mass of 2 kilograms, and it moves at a constant speed of 4 meters per second. What's its kinetic energy? So I know that kinetic energy is 1/2 mv squared. So it's 1/2 of 2 times 4 meters per second squared. And when I do this on my calculator, it comes out to be 16 joules. Or I can do it in my head, because 4 squared is 16, and the 2 and the 1/2 cancel. So the answer here is going to be B. All right, number 6. If the speed of a car is doubled, what happens to its kinetic energy? So again, I'm just going to write the equation. Kinetic energy is 1/2 mv squared. So now it says what happens if I double this? So it would be 1/2 m 2v squared. So let's just multiply that out. So 1/2 m 2, this would be 4v squared. So the difference between this and this is this 4. So 4 means it's going to be 4 times, which is quadrupled. So the answer there is going to be A. Number 7. Each of the blocks in the diagrams lifted vertically for the distance indicated, which has the greatest gain in gravitational potential energy. Well, I know that gravitational potential energy is mgh. Well, they don't give me the mass, they give me newtons. Well, newtons is mg, because F of g is mg. So this is basically the weight times the height. So I just have to multiply them. So 2 times 4 is 8. 3 times 4 is 12. 3 times 3 is 9. And 5 times 2 is 10. So the one that has the largest number is this one. So the answer is going to be B. All right, let's get a clean piece of paper and do the other side. Here, move the calculator. We will fold this in half, have more space. There we go. All right, so here we go. Number 8. A 1 kilogram book is resting on the ground. It moves 1 meter. So again, it's going to be mgh. So potential energy is mgh. So this is moving 1 meter. Well, this is not going to be anything because the force, mg, and it says the gravitational potential energy is going to be the mass times gravity times height. Okay, so this, the one that's going to obviously make the most difference is D. Because it's going to be mg times that 1 meter. Here, we're going to have components. All right, number 9. A 1 kilogram mass rests on a horizontal surface. How much kinetic energy is needed to accelerate the mass to a speed of 5? So the mass is 10. And they want the velocity to be 5 meters per second. So we know kinetic energy is 1/2 mv squared. So it's 1/2 of 10 times 5 meters per second squared. So 25 times 10 to 50 divided by 2. Again, we can do that in our head. So the kinetic energy is 125 joules. So the answer there is B. All right, number 10. So it says, as the pendulum swings from A to B, what is the relationship of kinetic to potential? Okay. So remember, at the bottom, this is our frame of reference. So this is where the potential energy, the gravitational potential energy is 0. And at the top, this is where the potential energy is a maximum and the kinetic energy is a minimum. So up here, if it's not moving, it's going to be all gravitational potential energy, mgh. As it starts to fall, the velocity is going to increase, so the kinetic energy is going to increase, but it's getting closer to the ground. So as the kinetic energy increases, the potential energy decreases, but the total energy is the same. So when I read all the choices from here for number 10, again, at rest, the kinetic energy is 0. As it starts to fall, the kinetic energy increases and the potential energy decreases as it gets closer to the ground, which is base level, but the total energy remains the same. So the answer here is going to be choice D. The kinetic energy increase is equal to the potential decrease. That's just really conservation of energy. They could have asked us more questions there. All right, number 11. A 2 kilogram mass falls freely for 10 meters near the surface of the Earth. The total energy gained by the object during its free fall is, so this is, again, conservation of energy. So to do this one, number 10, we can say the mass is equal to 2, and the height is 10 meters. So conservation of energy says the total energy before is the total energy after. So PEI plus KEI is equal to PEF plus KEF. Now initially, the kinetic energy is 0, and then at the end, the potential energy is 0. So we have MGH, this, is equal to KEF. And that's all we want is the kinetic energy. So the mass is going to be 2 kilograms times 9.8 meters per second squared times 10 meters is equal to KEF. When we do that on our calculator, KEF comes out to be 196 joules, but this is only one significant figure. So when we round our final answer to a one significant figure, it would be 200 joules. And that's number 10. All right. Number 12. So we have a force versus distance graph. So what do we need to know? We need to know on a force versus distance graph, the work is equal to the area under the curve. Okay, so the curve is, I have this area, which is a square, and then this one, which is a triangle. So I am literally doing this area plus this area. So the work is going to be base times height plus 1/2 base times height. So the work is going to be, this base is 3. This height, I'm just reading from the graph, is 6. Plus 1/2, 3 to 6 is 3. And then this height is 6. So 6 times 3 is equal to 18. Plus 6 times 3 is 18 divided by 2, 9. And 18 plus 9 is 27 joules, which is answer C. All right, number 13, which quantity measures the rate at which work is done? So that's just the definition. So power is work over time. So that's going to be B, and that's just the definition. Because rate has to do with the time. All right, number 14, as an object falls freely in a vacuum, the total energy remains the same. This is conservation of energy. And number 15, which graph represents the relationship between the gravitational potential energy of an object near the surface of the Earth? So we know that gravitational potential energy is equal to mgh, okay? So basically, as the height, so we have potential energy versus height. This is the mass, which is constant. This is gravity, that's constant. So as this increases, as h gets bigger, what's happening to that? That's also going to increase, and they're directly proportional. So directly proportional is a straight line like this. So as the height increases, the potential energy increases at the same rate. So the answer to number 15 is going to be A. And that's it.